As part of section 5.2, we're going to look at the signs of functions and their ranges as well. So signs is talking about like positive, negative. So if you draw a quadrant or XY plane, you have your first quadrant, right, your second quadrant. And there's an easy way to remember this. Which signs go where? And that's cast. Another way is remembering all students take calculus. So when we look at an XY plane, like here's our x's, right, here's our y's. To the right, if I have a point somewhere up here, my x is positive, right, and my y is positive. And then over here, my x is negative, my y is positive. Down here, my x is negative and my y is negative. And in the fourth quadrant, my x is positive and my y is negative. Okay? So as we think about if we have some point out here and say that this distance to 0, our r, right? Say our r is equal to 1. Okay? And as we go around 360 degrees, our r stays 1. So in every quadrant, our r is going to stay 1. So as I look at my sine of theta is equal to y over r. And remember, our r doesn't even have to be 1 here, really. But our r is the distance to 0, right? Well, isn't that always going to be positive when we're talking about distance? So r is always going to be positive. So in this quadrant, isn't my y positive in quadrant 1? So my y over r would be positive. So sine is positive in this quadrant. Cosine is x over r. And tangent is y over x. Aren't those all positive? So that's why they're all positive here. So all the trig functions, all 6 of them are positive here. In the second quadrant here, my sine is y over r, and r is positive, so y is positive, so positive over positive is positive. So sine and its reciprocal, cosecant, are the only positive ones. Cosine is negative because I have a negative x, and cosine is x over r, so that'd be negative over a positive is a negative, and tangent is y over x, so that is also negative. In the bottom quadrant, y over x, tangent is negative over negative, which is a positive, so only tangent and its reciprocal, I guess I can put those angles, and cotangent are the only positive in the third quadrant. In the fourth quadrant, I have my x is positive, so x over r is positive, so that means cosine and its reciprocal, secant, is also positive. So cast is a way to remember this. C, A, so C for cosine and its reciprocal, A for all of them, S for sine and its reciprocal, and T for tangent. So that's how you can remember cast. Another way is all students take calculus. So that's another way to remember an acronym. So that's how you can tell whatever quadrant you're in, you can tell which trig function, if your trig function is going to be positive or a negative answer. Right, so that's the sign of a function. Now let's go ahead and look at some examples. Okay, so here's 3 angles, and we want to see what are their signs. Well, 87 is, here's 90, right? Here's 180, here's 270, here's 0 and 360, right? So 87 is somewhere in the first quadrant. So what are all of them? Since I'm in the first quadrant, 87's in the first quadrant, somewhere like this. That's 87. So all of them will be positive there. So all sines will be positive. So sine of 87 is positive, cosine of 87 is positive, tangent and all their reciprocals will all be positive. How about 300? Well, where does 300 go? It starts here, opens up, passes 270, doesn't quite get to 360, right? So it's somewhere like this. Well, I'm in third quadrant. That means cosine of 300 and its reciprocal secant of 300 are the only positive ones. Everything else will be negative, right? And then minus 200. So I start here, and minus I go down. So there's 90, 180, negative 270 is right here. So I can't go all the way that way, right? So I need to end somewhere over here, negative 200, maybe a little past 180, right? So here's my angle. Now I'm in the second quadrant, so only sine and its reciprocal, negative 200, will be positive. All the rest will be negative. Okay, so here you're trying to identify the quadrant where sine of our angle is positive, right? Greater than 0 means positive. So sine is positive, so where is sine positive? And tangent of our angle is less than 0, so that means negative. And tangent is negative. Okay, so sine is positive. And these two, right? Where is tangent negative? Well, tangent is negative in this one and in this one, right? So where do they overlap? Right here in the second quadrant. So quadrant 2, you'll have all your sines will be positive and all your tangents will be negative. Okay, here's another one. Where if cosine is less than 0 and secant is also less than 0? So that means that cosine is negative and secant is negative. So where are they both negative? Well, cosine is negative here and here. Oh, sorry. Cosine deals with x. Here and here. So, and because these are reciprocals, I can't narrow it down from there, right? Where secant is negative is the same place where cosine is negative. So this could be quadrant 2 or quadrant 3. So I can't narrow it down past those two. So as we look at the signs of them, now we'll look at the range. Range meaning your answers, right? What are the answers of sine of theta, of cosine of theta? So meaning, okay, if I plug in sine of, say, 78 degrees, what type of number will I get out? When I plug in cosine of 78 degrees, what type of number will go out? Well, what happens is, whatever you're going to plug into sine and cosine, right, it's going to repeat itself every 360 degrees. Well, it turns out that my range of answers for sine of an angle or cosine of an angle will always range from -1 to +1. So I will always get fractions, mostly fractions. Sometimes I'll get -1 or +1, right? We saw that at 90 degrees and at 180 and at 270 and at 0, right? We got 1 and -1, those type of answers for sine and cosine. But all answers are going to be between -1 and 1. What about for tangent and cotangent? Well, it turns out for those, we could have any real answer. So from -infinity to infinity. And then secant and cosecant, because they're reciprocals of the -1 and 1 there, what do you think the range for secant and cosecant, since they're reciprocals of sine and cosine? Their answers will be everything but -1 to 1. So -infinity up until -1, and then from 1 to +infinity. So they will always range. You'll never have an answer of secant and cosecant between of a fraction between -1 and 1. right? You'll never have an answer outside of 1 and -1 of sine or cosine. So let's take a look at some of these and see if it's possible or not possible. So is it possible to have a sine of 2.5? Look at our range. Is 2.5 inside that range, -1 to 1? No, it's not, so not possible. Can I have a tangent of 11.73? Does that fit within our range of -infinity to infinity? Yes, so this is possible. What about a secant of 0.06? Isn't 0.06 between -1 and 1? But I can't have anything between -1 and 1, so this is not possible. Okay, so suppose you have an angle that's in quadrant 2. Okay, that's what this is talking about right here, quadrant 2. And sine of that angle is 2/3. So 2/3. Can you find all the other 6 of them? Okay, so can you find cosine of theta? Can you find cosecant of theta? Can you find secant of theta? Can you find tangent of theta? Can you find cotangent of theta? Well, cosecant of theta is just the reciprocal of 2/3, right? So that's 3/2, so we're good there. We know we're in quadrant 2, so we know the only positive one is sine and cosine, so we know all the others are going to be negative answers. So we could go ahead and mark those all negative. Now we can use the fact that sine of theta is equal to y over r. And sine of theta right now is equal to 2/3, right? So that means my y is 2, and my r is 3. And now I can go ahead and solve using Pythagorean theorem kind of backwards, right? Because we do r squared is equal to my x squared plus my y squared. Well, my y is 2, my r is 3. Now we're just solving for x. So 9 equals x squared plus 4. Subtract 4, we get 5 equals x squared. Square root the 5. We can leave it as square root 5, that's fine. So there's our x. So cosine is x over r, so that's root 5 over r, which is 3. Right? But we already know it's going to be negative because we're in the second quadrant. Secant would be the reciprocal of that. We'll work on that a little bit, but let's do tangent. Well, I guess we can do this. So that would be -3 over root 5, but we can't have root 5. So remember, when dividing by root 5, or divided by any root, we want to multiply by itself, right? Because we want to get rid of that square root on bottom, and we need a pair on bottom because that's what square root's asking for, what times itself. So I get to pull 5 out. So let's go ahead and correct that to a 3 root 5 over 5. So -3 root 5 over 5. Tangent is our y, which is 2 over root 5. But again, I'm dividing by root 5. Same thing here, so I'm not going to multiply root 5 and root 5 on top and bottom. So we're not going to have a root 5 over 5. So this time instead of 3, because it's not my r, it's my y, right? So it'd be 2 root 5 over 5. And cotangent would be flipping that. So that would be root 5, because it's it's x over y, and my y is 2. So there's all 6 of them. Okay, a little pointer here. Whenever you have a number divided by a square root, we want to rationalize that. And it turns out we always multiply by itself right on bottom, and then we have to do that on top too. So we get 3 root 2 over 2. So what's the real difference? So whenever you divide by root, can you just say that you're multiplying by that root over what's underneath the radical? Right, called the radicand. What's underneath the radical is called, this is the radicand, 2 is the radicand. So if I have any number divided by some square root of a number, isn't that just going to turn to that number in the numerator times by that square root over what's inside the square root? It will always turn to that, right? So you could use that if you want to, or you can continue to rationalize, but you'll end up that way anyways. Alright, so on page 498 you have 87, 89, 93, 101, 107, 109, 113, 115, 129. Look at all those problems, there's a lot of them, right? Well, let's get going. Number 87. So number 87 is just asking, okay, what are the signs of all the 6 trig functions, right? If it's in standard position, given the angle. So 74 degrees. So 74 degrees, it's not quite to 90, right? So it's in the first quadrant, right? So we're in quadrant 1. So they're all positive. So you just say all positive. Okay, let's look at 89. Okay, 218. So 90, 180, 270. So we're somewhere down here, right? So that's the third quadrant, quadrant 3. So what's positive there? Tan and cotangent positive. Sine, cosine, cosecant, secant, negative. Okay, number 93. Negative 80. So this would be negative 90. So negative 80 is somewhere over here. So we're looking in quadrant 4. So what's positive in quadrant 4? That is cosine and secant. Positive. That means all the rest are negative. Cotangent, tangent, cosecant, sine, negative. Okay, so here we're looking for the quadrants on number 101 and 107. So where's tangent negative? Less than 0. Tangent is negative, right? In this quadrant and in this quadrant. And where's cosine negative? Cosine is negative in this one and in this one. So where do they overlap? In quadrant 2. Okay, where's sine negative? Sine is negative down here. Where's cosecant negative? Well, cosecant and sine are reciprocals, so they're still negative in those two places. So either quadrant 3 or quadrant 4. Alright, here you're telling if this is possible or impossible. Can sine be greater than 2? Or can sine be greater than 1? Or greater than negative 1? Or smaller than negative 1, I guess you'd say. No, it can't, so that's not possible. Can tangent be anything? Yes. Can secant of theta be a decimal, even a negative decimal, between negative 1 and 1? No, it cannot. It's possible. Okay, so there's those ones. Now let's go ahead and look at number 129. Okay, so they give us a sine of theta equals 5/7, and we're in quadrant 1, it says. So our angle's in quadrant 1. So since we're in quadrant 1, what do I know the signs of the rest of the 6 trig functions? Well, since we're in quadrant 1, that means all, right? So they're all going to be positive. So that means sine is positive, as we know it's 5/7. What about the reciprocal cosecant of theta? Well, that would also be positive. We just flip that fraction, right? And dividing by root 5 is the same as multiplying by root 5 on your numerator, and then dividing by what's inside that radical, which is 5. So there it's rationalized. Okay, cosine. This one we're gonna have to do more, but we know it's positive. We know tangent is positive. We know secant, the reciprocal of cosine, will be positive, and so will cotangent. So we know they're all positive. Now sine again is equal to y over r. So that means we know our r is 7 and our y is root 5. So now we could use Pythagorean theorem. X is equal to our r squared minus ry squared, square rooted. So r is 7, so 7 squared is 49. Root 5 squared is 5. Square root that after we subtract, so we get 42. So we can leave it as square root of 42. That's fine. And now we want to go ahead, and now that we have our x, we can do cosine. Cosine is x over r, so square root of 42 over 7. Tangent is y over x, so that would be root 5 over root 42. We can go ahead and start simplifying these as well. I guess I didn't add or subtract right, so this is 45, no 42. That would make it easy, because then we can simplify to 2 root 11. So 2 root 11, so we can switch this one, switch that one. 2 root 11. Okay, 2 root 11. We can rationalize this tangent one, because when we're divided by the root, remember we just multiply by that. Root times the numerator and times the denominator. So it'll be 2 times 11 on bottom, and then root 55. So this would be root 55 over 22. Okay, and then we can go ahead, do secant, flip that one. That is 7 over 2 root 11. If I'm dividing by root 11, that means take my numerator and multiply by root 11, and then multiply my denominator. Well, my denominator would be 11, but I have a 2 down there, so I need to multiply that by that 2, so I get 22. Cotangent is flipping that, so we got root 5 on bottom, so we have 2 root 11 on top, because our x is on top, and our y is on bottom. Now we can rationalize that. If I'm dividing by root 5, that means I'm multiplying the numerator by root 5, and the denominator just becomes the radicand of 5. Okay, so those are our 6 trig functions.